Lesson 2.3, Relative Frequency Probabilities. Our objective for this lesson is to be able to use the relative frequency method to find the probability of an event. We're going to start by defining some terms. All right, our first term is relative frequency probability. This is a method of approximating probability by making observations and counting how often the event occurs. In the last lesson, we talked about theoretical probability, and that was based on the assumption that all outcomes were equally likely. But for many events, it's not possible to have a theoretical probability. Instead, we need to approximate the probability by just doing an experiment over and over again, or making an observation over and over again, in order to see how often the event occurs out of the total number of observations that we made. That's going to give us our relative frequency probability. Now, along with relative frequency probability, an important concept is the law of large numbers. The law of large numbers says that the more often an experiment is repeated, the closer the relative frequency probability gets to the theoretical probability. So, for example, if I want to know the probability of getting heads if I toss a coin, well, the theoretical probability is pretty straightforward. There's one way that the event can occur, I get a heads, and out of two possible outcomes, a heads or a tails. So the theoretical probability is 1 divided by 2, or 0.5. But if I toss a coin a small number of times, let's say 5 times, the relative frequency probability may be way off. I may only get 1 heads out of those 5 tosses, and that's going to give me a relative frequency probability of 0.2, 1 divided by 5. But if I toss that coin a lot of times, let's say 1,000 times, then I'm going to be fairly confident that if it's a fair coin, that I'm going to get 500 heads and 500 tails, or pretty close to 500 heads and 500 tails. That's the law of large numbers. All right, now to find a probability using the relative frequency method, the first thing we're going to do is do an experiment. We're going to repeat or observe a process many times and count the number of times the event of interest, A, occurs. And then step 2 is to estimate the probability of A using the formula. The probability of A is equal to the number of times A occurred divided by the total number of observations. So if I flip a coin 1,000 times and I get 503 heads and 497 tails, then our probability is going to be probability of getting a heads is 503 divided by 1,000, or 0.503. An example of the way that we use the law of large numbers is with car insurance. Now, there's no way to use the theoretical method to determine how likely it is that someone's going to be in a car accident, but we have all of this data on car accidents that allow us to find a relative frequency probability. When you go to an insurance company, they'll sell you a policy that says, in the event that you're in an accident, we'll pay for it, but in exchange, you're going to pay us a certain amount per month. Now, in order for the car insurance company to know how much to charge you so that they come out ahead after they've paid out all these accident claims, they have to know how likely it is that you're going to be in an accident. Well, they can't predict whether or not you're going to be in an accident, but out of their millions of customers, they have a pretty good idea how many of those are going to be in an accident. And so that's what allows them to use, to set their rates. The first example asks us to perform an experiment with 100 trials and to use the relative frequency method to find the probability of getting a tails when you flip a coin. To do this first example, we need to toss a coin 100 times. And rather than use a real coin, I'm going to use a simulator that I found on the internet. And the link to this simulator is in the description. So here, this simulator allows us to simulate one toss at a time, or as up to 1,000 tosses at a time. So I'm going to start with just one at a time, and I'm going to start by tossing this coin. And the first toss comes up tails. And remember, we're looking to see how many tails we get divided by the total number of tosses. That's going to give us our relative frequency. So I got a heads. Now another tails. Now another heads. Then a third heads. Another heads. Now tails. Another tails. Another tails. And another tails. So out of the first 10 tosses, we had 6 tails. So we had a 6 in 10, or a 0.6 probability of getting a tail. So it was 60% relative frequency probability of getting a tails. This is a ways away from our theoretical probability of 50%. We're off by 10 percentage points here. So let's, instead of continuing to toss these one at a time, let me go ahead and just simulate the other 90 tosses right now. And let's see what we get out of 100 trials. All right, so now you can see that we've come very close to our 50% probability, or our 0.5 probability that we got with the theoretical method, or that we would believe we should get from our theoretical method. And we can see that we got 49 out of the 100 tosses were tails. So 49 divided by 100 is going to give us a probability of 0.49, which is very close to our theoretical probability of 0.5. For the second example, we're again asked to perform an experiment with 100 trials and use the relative frequency method to find the probability of getting a 7 when you roll 2 6-sided dice. And for this example, I'm going to roll 2 actual dice 100 times, and we're going to try to count the number of 7s we get. All right, so I counted 17 sevens in those 100 rolls. And so to find our relative frequency probability, we're going to take that 17, the number of sevens that we got, divided by the number of rolls that we had. So we had 100 rolls. So 17 divided by 100 is equal to 0.17. So that's our relative frequency probability. Now, to compare that to the theoretical probability that we found in the last lesson, we said that there were 6 ways to get a 7 out of 36 possible outcomes when you roll 2 dice. And 6 divided by 36 is approximately equal to 0.167. And so you can see our relative frequency probability with just 100 rolls came out to be very close to the theoretical probability. That's it for this lesson, and I would challenge you this week to think of an experiment that you could do to come up with a relative frequency probability that's of interest to you.